So this is the first problem of Irodov, and the first section in Irodov's book deals with kinematics. So this is a kinematics problem. Let's get to it. The problem says that there is a motorboat which is going downstream, which is another word to say that the boat is going in the same direction as the stream. At a certain point A, here it comes across a raft and it passes it and it continues to go downstream for an hour after that. So from A to B it takes an hour, and at point B, let's call it point B, it takes a U-turn and then it goes upstream, which means in a direction opposite to the flow of the river, and it reaches a point C where it once again spots the same raft, and this point C is at a distance of 6 kilometers from the point A. We have to find the flow velocity, that is the velocity of the river, assuming that the motorboat engine duty is constant. And so this is what the schematic of the problem looks like. And we introduce two new parameters, V0 and V1. So V0 is the stream velocity and V1 is the velocity of the motorboat with respect to water. The motorboat, when it is moving from A to B, will have a velocity of V1 plus V0. So these velocity will get added as it moves from A to B. And as it moves from B to C, we don't know how long it takes, but the velocity as it moves from B to C will be V1 minus V0. The raft, it flows from A to C, and its velocity will be same as that of the river. So the raft will move from A to C in the same time which the motorboat takes to move from A to B and then B to C. So its velocity will be V0, which is same as the river. It does not have a motor attached to it, so it flows at the same velocity as the river. So the important thing to notice in this is that the time in which the raft goes from point A to C is the same time which the motorboat takes to go from A to B and B to C. And we need an equation that expresses the same. So let's get to it. The time taken by the raft to go from A to C is equal to time taken by the motorboat to go from A to B plus time taken by motorboat to go from B to C. Now we just have to write an equation for this. So the time taken by the raft to go from A to C, the time will be equal to the distance divided by the velocity. The distance is given to us. It is 6 kilometers, and the velocity we know is V0. So the left hand side of the equation will become L divided by V0. So the velocity of the raft is same as that of the river, and the distance traveled by the raft is L. Its value is given to us as 6 kilometers, but we can put it later if we need to. And the time taken by the motorboat to go from A to B, so that is 1 hour, and it is given to us. So we can use the variable tau for it, and that is its value is already given to us, but we can put it later. And time taken by the motorboat to go from B to C will be equal to the distance BC divided by the velocity of the motorboat from B to C. We already know that as the motorboat goes from B to C, its velocity is v1 minus v0 right here. So we can write v1 minus v0. Now we need to find out what is the value of BC. So this distance we need to find out. We don't know how much this B to C distance is. So first we need to find that out. And so we write this equation again. L by v0 is equal to tau by BC. BC can be written as AB minus AC. We already know what AC is, and we also know what AB is. So L by V0 is equal to tau plus AB is nothing but the distance traveled by the motorboat in 1 hour as it goes with a velocity of v1 plus v0. So we've got these two things here, and we can write down this, we can use this to find the distance between A to B. So AB will be equal to v1 plus v0 multiplied by the time that it takes, and minus AC. AC, we already know this distance. It is given to us as 6 kilometers, but we can just use the variable L. So instead of AC, we can write L, and we get V1 minus V0 in the denominator. So we've got our equation here. Now we just need to solve this equation. And so it will take a few steps. We'll take a common denominator, V1 minus V0. The next step, we just expand the terms in the numerator, v1 tau minus v0 tau plus v1 tau plus v0 tau minus L divided by v1 minus v0. We see that a few of the terms cancel out, so this one cancels out, this one cancels out. The equation simplifies, and we get L by v0 is equal to twice v1 tau minus L divided by v1 minus v0. Now we can just do some cross multiplication here. So we get L into v1 minus v0 is equal to v0 multiplied by 2 v1 tau minus L. Once again, we expand this. These two terms cancel out. We are left with LV1 is equal to 2 V1 V0 tau. V1 cancels out, and we get L is equal to 2 V0 tau. We can find V0 as L divided by 2 tau, and this is our final answer. We were supposed to find the velocity of the river, and we get L divided by 2 tau. We can now substitute the values. L is given to us as 6. 2 times tau is 2 times 1. So this is 3 kilometers per hour is the flow velocity of the river. And that is our answer. Thank you.